So I'm going to introduce this idea, this concept of impulse here, and I quite often do this at GCSE level with my higher sets because it's good preparation for later work, and also it really makes it clear about how it can be used to describe changes. If we want to change the force of an impact, then we can just change the time involved. So impulse is just a change in momentum. An impulse is a sudden force applied, usually for a short period of time, to an object that's capable of moving, or an object that is moving. So for example, you could be bringing something to a stop, to a standstill, that's already moving, or you could set something in motion. And to do that, you need an impulse, and it results in a change in momentum. So it's the same thing. So for a force F applied to a mass m, you start with Newton's second law, F equals ma. Then instead of acceleration, we're going to substitute in this change of velocity divided by the time taken for that to happen. So if something comes to a standstill, then its velocity after the impact is going to be 0, and v1 is going to be some number greater than 0, and then divided by time taken. If we multiply through by t, then we get F times t equals mv2 minus v1. Expand out the brackets, F times t equals mv2 minus mv1, and this is just the change in momentum. We've only got here, this is the momentum after the impact, and this is the momentum before the impact. Impulse is a vector quantity, just like momentum. The magnitude of an impulse is the change in momentum it produces. The direction of the impulse is the direction of the force. So just to recap, an impulse is a sudden force applied for a short period of time. An impulse causes and is equal to the change in momentum. The units of impulse are Newton seconds, or kilograms meters per second, which is exactly the same as the units for momentum. And impulse is force times time, which is change in momentum. Let's have a look at an example calculation. A golf ball of mass 45 grams, so 0.045 kilograms, is struck with a force of 180 newtons for a period of 0.005 seconds. Calculate the magnitude of the impulse. For this, we don't care what the mass is, we just care about what the force is and the time of impact. So impulse is force times time. 180 multiplied by 0.005 gives us 0.9 Newton seconds, or kilograms meters per second. Calculate the speed of the golf ball immediately afterwards. Impulse is change in momentum. This here, if we need a speed, right, so we can use this, we know what the impulse is, but we need to rearrange the equation for v after. So the change in momentum is momentum afterwards minus momentum before. It's the change in momentum. So mv after minus mv before. Now mv before, that's the momentum of the golf ball before it's been hit. So it's just waiting on its tee to be hit by the golf club. So it's not moving anywhere, so therefore its momentum is 0. So this just becomes 0.9 equals 0.045 v after. Rearrange for the unknown, v after equals 0.9 divided by 0.045 equals 20. So the speed of the golf ball immediately afterwards is 20 meters per second. So you can see how useful this is. We can apply impulse just the same way as we were doing before with a change in momentum.